So we're going to be using our ICP-MS today. This is the ICAP-RQ from Thermo, and the ICP-MS is the Inductively Coupled Plasma Mass Spectrometer. And so this is a really commonly used instrument in industry to do water quality testing, food safety testing, where you can take basically any liquid or solid and you can look at what elements are present there. So a really common thing is to look for heavy metals, so like arsenic or lead, and make sure that they're present in low enough levels that they wouldn't be harmful to humans. And so that we're able to do using this instrument by putting in our samples and using a set of standards alongside our samples. First off, we're going to go through how to turn on all the components to get the plasma up and running. First thing we're going to do is turn on the chiller down here. So you can turn on a button, hear a noise going, and we're going to want this to get down to about 20 degrees C. All right. And then the next thing we're going to do is open our gas. So this is a tank of liquid argon gas. I'm just going to open some of the valves. You'll see the needle start to go, and there's another valve up here. You can kind of hear the gas, and that'll be going through now to the ICP. And the last thing we're going to turn on is the auto sampler. And we'll start to see this little arm move around a little bit as that auto sampler turns on. And then after that, we need to get the sample line put into this peristaltic pump. And this we want to do so that when it goes clockwise, your sample is going to go into the nebulizer. And so it's a little bit tricky to do, but if you just figure out which direction your line needs to go, and you place it into these little clips. And then the same thing's going to happen with the waste line. You're going to have it go clockwise into the waste down at the bottom. And then we're going to clamp those both shut so that now we can pump our sample through the pump when we activate it with the software. So at this point, the instrument is ready to turn on, but we're just going to look inside real quick. So this door has a safety lock, but this kind of shows you where the plasma is actually going to turn on inside the instrument, and that's where your sample is going to go in until it gets into the rest of the mass spec. All right, and now that we've set up everything on the instrument, we can go over to the computer and turn on the plasma. And the computer program we're going to start with is instrument control down here. So we're going to open that up. We're going to have our little periodic table display, and what we're going to want to do is turn it from off to on. So we're going to press on. We want to say yes, we want the plasma to be switched on, and it's going to start going through some settings and try to turn on that plasma. And the other thing we can look at is we can pull up a camera that is looking inside that chamber that we just opened to see if that plasma is going to turn on successfully. All right, so it didn't work for that first try, but it's going to try 3 times and see if it gets it on the second try. There we go. All right. So now we have the plasma turned on, so the instrument is running, and now we can start to control some of our samples with the software. And first thing we're going to do is we're going to put the auto sampler into our blank solution. And so we're going to go to the auto sampler tab on the instrument control and move this into position 1 on rack 0. And we'll be able to see that on the auto sampler. We'll move in to our first tube. And this is going to take about 30 to 40 seconds for the liquid to get moved by the pump through the tubing into the instrument. And while we're doing that, we can start monitoring the data by clicking the Run button on the instrument control. We'll get a real-time readout of some of the elements that we're looking at the moment. So we're looking at iron and titanium and barium, and just kind of seeing how much of that is in the current solution in the instrument. So at this point, once the instrument's running, we're going to let it warm up for about half an hour using that 2% nitric solution, the blank. And we're going to start putting in our samples into the auto sampler to get them ready to run once the instrument's finished warming up. And for your actual samples, you're going to want to have a blank solution. Take the cap off, put it in, and then you want to have a set of standards that make a standard curve, and then your unknowns, which should fit within that standard curve to look at whatever elements of interest you're looking at. And with my standard curve, I'm going to go from the lowest concentration samples to the highest concentration. And then I'll put in my unknown samples. And so in this case, these are just water samples taken from Pine View Reservoir. And so once all those samples are put in there, we can close the autosampler lid. And I'm following, there's a guide here that kind of shows you what the numbers of each of these samples are going to be corresponding to in the computer software. So now we'll go over and tell the computer what samples we have so it knows where to take the samples from. So we want to keep an eye on the instrument control and make sure that we're collecting data so that the instrument's still working. And while we're doing that, and after we put in our samples, we can start creating what this software is called a lab book. And a lab book is kind of a collection of your samples and your standards together. And that's going to be done in Qtegra. So instead of the home screen is usually this dashboard, which looks similar to the instrument control, but we're going to go into lab books. And we're going to create a brand new lab book, give it a name. Today we're just calling it water testing. And then we're going to choose a blank template, so we're going to create it from scratch today. So I'm going to create this lab book. And the first thing you're going to see when you create the lab book is the periodic table. And what this is going to allow you to do is you can select by left clicking. You can select any elements that are of interest in your sample. So here we have titanium and chromium and manganese and iron and cobalt. And maybe we'll look at magnesium today. One other thing you can do is you can also right click and you'll get the different isotopes of that element. And so in this case, we have 4 isotopes for iron, and it's when you did the left click, it defaulted to this 57 iron, and that is lower abundance, but what it also gives you is it tells you about interferences. So this 56 iron actually has the highest abundance, so you'll get the best signal, but you also get the most interference because our carrier gas is argon and oxygen is present in the atmosphere, and so those will combine together to create a lot more signal than your iron sample. So it's actually safer to take this lower abundance 57 iron. And once you've chosen your elements, the other really important thing is to go back and tell the instrument what kind of standards you just put in there. So in this case, we're going to create an elemental standard, and we're going to use the standards from the analyte list that we just chose in the periodic table. And we're just going to call this our multi-element standard. And you should know ahead of time what the concentrations of your elements are in your standard. And in this case, we actually have a bottle that tells us very easily what these are. So we have high concentrations, what we call majors, and low concentrations. So these are at 1,000 micrograms per mil, the high, and 10 micrograms per mil. And so I can kind of associate that with my standard that I'm putting in the computer. So for magnesium, I can put in, this is going to be 1,000 ppb. And then for the rest of these will be 10. Chromium, manganese, iron, actually it doesn't have iron, but that's okay. Copper and nickel. So that way we have an array of concentrations. And the next most important thing is we're going to create our sample list. And the sample list is where you're going to put in your standards and your unknowns. So I can add rows, kind of like Excel, use it, and you can add in your labels. So first thing I put into the autosampler is a blank, and then I put in a standard 1, standard 2, standard 3, standard 4, and standard 5. And so this is going to be really important where you double check what actual samples you have in the autosampler and where you place them in the autosampler by checking that the actual numbering of the tubes. And so I'm going to get rid of some of these columns because they're just kind of confusing. But if we go back and look, we can actually kind of have a cheat sheet right here in our auto sampler instrument control where we can hover over our racks. And so our rack that we're working with right now is rack 3. So I can do rack 3, and I can also fill this down so it all goes to rack 3. And then I know that my blank is going to be vial 1, and then my standard is 2, 3, 4, 5, 6, and then my unknowns will be 7 and 8. So as long as you put them in the right order, they should be really easy to get the correct rack number and vial number. And then what I'm going to do is I'm going to tell the software that I have a standard here, and which standard is my melt to element standard. And then the same with the other 3 standards, or 4 standards. All those. And then my last ones are going to be called PineView 1 and PineView 2. And so the dilution factor, because I'm going from my lowest concentration to my highest concentration, my concentration of my highest one is going to be the same as you told the software. So whatever numbers you put here is your highest. So that'll be a dilution factor of 1. And in this case, most of the time we make a standard serial dilution of 10x for each. So I'm going to have a dilution factor of 10 for my next diluted one, of 100, of 1,000, and of 10,000. And then the last thing I need to do is tell it my survey runs, which just has the instrument check which element it's looking at before a run starts, is one survey run. And then I'm going to do everything in triplicate. So I'm going to do 3 main runs here. And I want to change this to a blank. So I'm going blank, my standards, and then my unknowns. The last couple things are to change your auto sampler. And so if you note it, if we go back to our auto sampler photo over here, yeah, it's going to be kind of hard to demonstrate. So it has 12 in a row here, which corresponds to the smaller rack. And so we're actually going to change what the racks are. So for rack 3 on the bottom there, it's going to be a 60. So that just corresponds to those smaller tubes. And we need to change the analysis time. So because those tubings are so long, it actually takes over a minute for the sample to get from the tube to the instrument. So I said uptake time of 65 minutes. And then there's going to be washes in between each sample to prevent carryover. And we're going to do 2 washes, one of 60 seconds and one of 5 seconds, just to make sure that everything gets cleaned off in between the samples, you don't get carryover. So once we've done all of those settings, we can save. We can double check that our rack number and our vial numbers are good. And we're going to click Schedule Lab Book with the green arrow. And then it should pop up down here at the bottom. And we'll get another green arrow. And we will start running the lab book. So you can kind of keep an eye on the errors over here on this instrument control. It says I didn't do a get ready first. That's just this big button that's red right now. I'm just going to tell it to warm. I already did let it warm up, but I'm just going to tell it I'm going to let it warm up for another minute. And this should change from red to green now. And hopefully this will be green. So once this is green, I can go back and try this again, schedule a lab book, and run it. And looks like I'm getting more successful here. And that's when we can walk over and kind of check our auto sampler and make sure that it's going to go down into the first tube, our blank tube, as long as everything is going correctly. All right, so that's a really good sign. we have our first sample, the blank in this case, being taken up by the autosampler, and it'll be going through the tube into the software. And now, what's really nice about the autosampler is no matter how many samples you have there, you can have up to 100, but you can just kind of walk away, come back later, and check on your data once it's finished running. And once our samples are finished, we can take a look at the data and see how everything turned out. And so you'll get a message down here saying that your lab book has completed successfully. And you'll also see that all your status icons on your samples are each green, indicating that it has been run. And the important things we want to look at here are the concentrations. So what's nice is that the software is going to plot all your standard curves for you. So it'll make a little plot with all your standards with the concentration versus the raw intensities that the data gets. And it'll also give you an R² value, which will indicate how good your standard curve was. So in this case, our magnesium standard curve was really good at 0.999. Our titanium standard curve was actually really bad at 0.317. And that is because titanium wasn't actually in our standards. So this is kind of something to look out for, is really your data is only as good as your standards are. So if your standard curve is not good, if it has a low R² value, then your data isn't really going to be worth looking at. Our other elements all have pretty good R² values. And so we can now look at our unknown data down here, our unknowns, and see that it has a pretty high concentration of magnesium, which makes sense because that's in a lot of stuff. And it does have actually a little bit of iron and manganese, but maybe not really any cobalt or nickel, which is probably good for water that we're eventually going to be drinking from. The one other thing we can look at is intensities. And like I said, this is the actual raw data that the instrument is getting, and that it's going to convert into those concentrations by plotting your standard curves. And so here you can just see, like, in general, everything is going up as your standards are getting higher, which is a good sign indicating that you made your standards correctly. All right, once you have your data, you can export it into an Excel file by exporting it in Excel format and telling it where you want to go on the computer. Usually you can just put it on the desktop. And that way you can look at your data. This is a CSV format, but you can do it in any other kind of format as well, to kind of look at it in the normal Excel style. So here it has your samples with the concentration, or here it's the intensities of those. All right, and once you have your data, now we're going to go back and shut down the instrument and kind of do everything in the reverse order that we turned it on in. So we're going to go back to the instrument control. And the one really important thing before we shut it down is we need to make sure that the whole instrument is dry. So we've been running liquid through it this whole time, and now we got to make sure it's dry. And the main way to do that is to take the autosampler and right-click and tell it to move home. And so what that's going to look like on the autosampler is that the probe will now be out of any of the solutions. It'll just be sucking in basically dry air. And what it's going to take 60 seconds like all the other samples. But what we're going to want is we take off these covers for the spray chamber. We want this to change from cloudy to clear. So right now it's looking really nice and clear. And so just to be safe, we'll probably give it an extra 30 or 40 seconds. But we want this to be a clear chamber and the whole system to be totally dry before we shut it off. And the reason for that is if it's got any liquid in it, the next time we try to turn it on, it's going to be really difficult because that light, that argon torch in order to light, needs to have a dry environment and not any liquid or water in there. So we'll just wait an extra 30 seconds. And kind of once we're happy with what that looks like, we can go back over to the software and get out of the autosampler tab, go to the ICP tab, and we're just going to click the big red off button. And it's going to say, please remove sample tube from any solution. Like we said, we want it to be dry. We're going to click yes. And at that point, it's going to do various shut off things. But the main thing you should see happen is the torch should shut off, which we can also see on the camera on the screen. This goes to black. And at the same time, the pump will stop running. And so once that pump stops running, we can undo all the little tabs and take it out so that pump tubing doesn't get stretched out. If you leave it in there, then that pump tubing will get flattened permanently, and we'll need to change it out because it works better when it's actually a tube. And the software is also going to be kind of telling us what it's doing. So it turned off the plasma, and now it's going to cool that glassware. So that's what the chiller has been for the whole time, is to make sure that glassware doesn't melt under the temperature of the torch. And we're going to let it go for another about 30 seconds to a minute, and it'll tell us that it's going to be in standby mode. And once it's in standby mode, then we can turn off the chiller and turn off our gas supply, and we'll be done using the instrument at that point. All right, so we finally got the standby message. So now everything is safe to turn off. And so we're gonna just do it kind of, it's not super important which order, but we'll turn off the chiller. That'll say it's turning off. And then we'll also close that valve on the argon gas and close the green valve as well to the actual tank. And at that point, you can collect your sample, and you'll have your data collected and exported, and you're good to go.